So to do this with a calculator, let's talk about some things we know about the unit circle and our quadrants. So we know on the unit circle, this is 0 and 2 pi. This is pi halves. This is pi. And this is 3 pi halves. If you don't know that by now, you are totally in the wrong place. So let's think about how we know, like if we get an angle and it's a pi fourths angle. So we talk about it as a pi fourths angle, even if it's 3 pi fourths, because that's the reference angle, right? So in quadrant 1, your first quadrant angles are always your reference angles. Okay. And your reference angle is referred to as alpha. So it's that weird looking A. So if we have a pi fourths angle, and I ask you, okay, what is the second quadrant pi fourths angle? Now, and you may all think about it a little bit differently now, but one of the things I showed you at the very beginning was we think in terms of fourths, right? So if this is pi, then this is like 4 pi fourths. So to get to the second quadrant one, we back up pi fourths and we get 3 pi fourths, right? So basically what we're doing is we're taking pi and subtracting alpha from it. Does that make sense to you? So this is technically pi minus alpha. We just think about pi as 4 pi fourths or 3 pi fourths or 6 pi fourths or whatever. Which means that when we get to the third quadrant then, if we had like 4 pi fourths, we'd go forward one and make it 5 pi fourths. So this is pi plus alpha. And then for your fourth quadrant, we say, okay, this is 8 pi fourths and I back up one. So this is actually 2 pi minus alpha. Okay. So does that make sense? Kind of connect with what we've done. All right. So one of the reasons we have to think about it this way is because we're going to have to use a calculator because we're going to have to take the inverse of values that we don't know. It's not just going to be the tangent inverse of square root of 3. It'll be like the tangent inverse of 1/3, which we don't know. I don't know that. So that's what you're going to have to use the calculator for. But then we're going to have to find it for different quadrants, and we're going to have to be able to reason around how we figure it out. And this is how we figure it out, because technically that's how you've been figuring out all the other angles. We just look at them a little bit different. Okay, so to make sure that we know whether or not our answers are reasonable, let's think about the decimal versions here. This is 0. Pi is about 3.141 something, something, something. Pi halves is about 1.570. And then this is about 4.712. Now, these are calculator problems. You're going to have a calculator. Do you have to have all that memorized? No, because worst case scenario, you can do pi divided by 2 and see what the decimal is. But just, you can at least think about, all right, I know pi is a little bit more than 3, so this has to be a little bit more than 1.5, and this is a little bit more than 3 halves. Okay, make sense? All right. I'm sorry, not a little bit more than 3 halves, a little bit more than 4.5 is what I meant. Okay, so everybody okay with all this so far? And then we'll look at how we're going to use all this. So we're going to solve each trig equation on the interval 0 to 2 pi to the nearest thousandth. It's 3 decimal places, and we have to be accurate to 3 decimal places. So we have to be able to use these calculators correctly, and don't get ahead of me on the calculators. Also, we need to make sure that these are in radian mode. Some of yours will be, some of yours won't be, because we used them last period, so let's just all double check. So turn it on, and you're going to do Shift Setup, which is right next to the on key. Choose 4 for radian, and then you should have a little tiny R up at the top. Okay, we all good with that? Well, make it. Okay. All right. And one thing this does not say, but I know it does say on your assignment, I just forgot to fix it on the notes. We find it to the nearest thousandth unless it's a special angle. If you end up with the sine inverse of 1/2, you better not put the decimal, you better put pi sixths. Okay, because those are the ones you should know. So we only use the calculator on values we don't know. Okay, or aren't supposed to know. Not my fault at this point if you don't know it. All right. So we're going to solve this just like we've been solving the rest of them. So this is going to give me 5 times the sine of x equals -1. So the sine of x equals -1/5. So x is equal to the sine inverse of -1/5. Once again, do not get ahead of me on the calculator. Don't start pushing buttons yet. Because what we want to figure out is we're taking the sine inverse of a negative number. So in what quadrants is sine negative? Third and fourth. So my answers are going to come from the third and fourth quadrant. That means I'm going to have to find alpha, and once I find alpha, this is going to be pi plus alpha, and I'm going to have to do 2 pi minus alpha. That's how I'm actually going to get those values. Okay, the calculator isn't just going to give me the values. Also, in the calculator, even though we are taking the sine inverse of a negative number, you always, I can't spell always use positive numbers in the calculator. Because our goal is not to get the final answer at this point, because there's 2 final answers and the calculator's not going to give me 2 final answers. I need to find alpha, the reference angle, so that I can actually find what I need to find. So that means even though we are taking the sine inverse of negative 1/5, in the calculator you're going to do the sine inverse of a positive 1/5. Okay, so do that. You can do that now. So do shift sine 1 divided by 5. And we get that alpha then is about 0.201. Something, right? Now, we're going to have to use this more than once, so we want to store it. This isn't the first time we've stored, so make sure you're pushing the buttons along with me if you don't remember. You do shift, recall, I would just use X, so right parenthesis. So then it should say that your answer is stored in X. Okay, so shift, recall, right parenthesis, or you know how to do it on that, right? So do we all have it stored? Do we have any questions? All right. So now that I have alpha, then I can actually find X. So the first thing to find X, I'm going to do pi plus alpha. So your pi is right in the middle on the very bottom. It's yellow, so you have to use shift. So we do shift pi plus alpha. So I'm going to do recall, right parentheses. So my calculator actually says pi plus X. It equals, and I get 3.343, comma. And informative, after your comma, you have to put a space. I know my handwriting doesn't always look like there's a space, but if it was typed out, it would look weird if there wasn't a space, right? So just make sure you're doing that. Then I'm going to do 2 pi, oops, hit the wrong button, 2 pi minus alpha, minus recall parenthesis. And we get 6.082. Any questions? What is what negative? I'm sorry. No, the trig value is negative. Our answers have to be between 0 and 2 pi. So these are angles, even though they don't look like angles, because we're used to our angles having pi's in them. So they have to be positive. Does that make sense? And the calculator shouldn't be giving you negative values, so you don't have to worry about putting them back in. The only thing you have to worry about is when you want to write it down this way, because you need to know that you're taking the inverse of a negative value, but in the calculator you use the positive ones. Okay, good question. Anything else? We all good? Awesome. All right, let's look at this. All right, so I've got 5 cosine x equals 2 secant x. So if I subtract it over and get a common denominator, I don't know that I want to do all that, but what is the reciprocal of secant? Cosine. So let's just go ahead and try that. So let's do 5 cosine x equals 2 times 1 over cosine x. Okay. So again, I could subtract it over, get a common denominator, but I'd rather avoid that if I could. Any other options you think I have here? Would you like to get rid of the fraction? How do we get rid of a fraction? Multiply by the denominator, right? So can I multiply both sides by cosine? Yep. When I do that, I will get 5 cosine x on the left, 5 cosine squared x equals 2. So that's nice. Then I can divide both sides by 5, so cosine squared x equals 2/5. Then I get that cosine x equals what? what do I write down first? Plus or minus. Do not forget the plus or minus. I've said that like a bazillion times this year, I know. Plus or minus the square root of 2/5. Because this is a calculator problem, I don't care that the denominator isn't rationalized. I only have to worry about that like if it's my final answer. So it's fine. I'm going to leave it like that because the calculator is going to do everything. All right. So that means then that x equals the cosine inverse of plus or minus the square root of 2/5. All right, so it's plus or minus. That means I'm using all 4 quadrants. This first quadrant's alpha. This is pi minus alpha. This is pi plus alpha. And this is 2 pi minus alpha. So I'm going to find alpha. That means in the calculator I'm only using the positive, so I'm going to do the cosine inverse of the square root of 2 divided by 5. And that gives me 0.886 something, something, something that I'm going to have to use a few times, so I definitely want to store it. And it'll just store right over the x that you had. So your x values, your first one is your 0.886. Then I'm going to do pi minus alpha. Actually, it will. Just do a square root. And then 2 divided by 5. It just equals. You don't even have to close anything. Okay? I mean, it's fine to do that too, but that works. Well, you have to store it first. So shift, recall, right parenthesis. Shift, and recall, and then right parenthesis. Okay, not sorting. So pi minus x. All right, y'all find the other ones. I'm going to pause so I get the phone. All right, so what you should have gotten then was 0.886, 2.256, 4.028, and 5.397. Do we agree with that? Any questions at all? All right, good deal. Okay, so then when I look at number 3, I have 4 cosine of x equals negative 7 sine x. If I move all that to one side, I'm not going to have a GCF to factor out. So what else do you think, how else are these related? What could I do? Cotangent or tangent? Okay, cotangent or tangent. If we use cotangent, are we going to end up moving it or changing it to tangent anyway? Yes, so either one is totally fine. But if I can start off with tangent, I'd rather start off with tangent because I know my tangent values and there's a tangent button on the calculator. But again, we could do cotangent and then flip it at the end. But if I divide both sides by cosine, I will get 4 equals negative 7 times the sine of x over cosine x. And then we know that sine over cosine is tangent. So 4 is equal to negative 7 times the tangent of x. So negative 4/7 equals tangent x. So x equals the tangent inverse of negative 4/7. We are finding the tangent inverse of a negative number. Tangent is negative in which quadrants? Try again. Second and fourth. First and third is when it's positive. Yeah. Second and fourth is when it's negative. Yes? We all agree now? Okay. It's all right. So that means this is going to be pi minus alpha and 2 pi minus alpha. So let's find alpha. You should get 0.519. let me know if you disagree. If you didn't get 0.519, what could you possibly have done wrong? Put the negative, because remember, you only use the positive in the calculator. Okay, we good? All right. So then, no, not alpha. So then our x values, once we store this, so shift, recall, right parenthesis on these, I've got pi minus alpha, 2.622, and 5.764. Make sure you're actually getting these. Don't just copy them down or you're not going to know what's happening here. But let me give you a little side note. If you're using a calculator that doesn't store numbers for you, I mean, there's still hope. It's not like you just can't do it at all. We know that alpha, yes, alpha is 0.519, but alpha is the tangent inverse of 4 over 7. Okay, like a positive 4 over 7. So when I go to find this, I could do pi in the calculator, pi minus the tangent inverse of a positive 4/7, and that would give me this answer. And I can do 2 pi minus tangent inverse of 4 over 7, and it gives me this one. Another option is if you're using the digital calculators like the one on Desmos or the one in Delta Math, when you type it in and you could do pi minus answer, before you hit enter, it shows you the answer, the actual answer in the end, and then you can just back it out and redo it, and you can just kind of keep using it. So just know how to manipulate whatever form of calculator that you are using. You're always welcome to come in here and use these, but just want to make sure you know you have options and figure it out. You're smart boys and girls. Any questions? All right, one more. So we've got tangent squared, 2 times tangent squared beta equals 7 secant beta minus 8. So how do you think maybe we should start by attacking this? Okay, so I could do tangent and change it to sine over cosine and secant into 1 over cosine, move it over, get common denominators and stuff. That's totally fine. What's another way? Tangent squared into the secant squared, right? And so if you think, I mean, sometimes you only see one way, and I understand that, and there's nothing wrong with doing the quotients and reciprocals. It just would take you a little bit longer. But if you think about, is there something else, and you think, ooh, one of them I can avoid fractions. I think I'm going to go with that one, because the fractions can get kind of weird in these, right? So let's do that. We've got this tangent squared beta. I can replace that from my chart, not from some magic land, into secant squared beta minus 1. And that's equal to 7 times secant beta minus 8. So I'm going to distribute my 2. Now I get 2 secant squared beta minus 2 equals 7 secant beta minus 8. So I substituted, I distributed. What should I do next? Do I factor right? I got to move it first, right? Okay. So I'm going to move everything to the left. You're right. I'm going to factor for sure. So 2 times secant squared beta minus 7 secant beta plus 6 equals 0. Okay, so I have a quadratic. Definitely have to factor. A is not 1. So I'm going to do 2 times 6. That gives me 12. So I need 2 numbers that multiply to give me 12, combine to give me a negative 7. 3. Negative 3 and negative 4. Good. So that gives me 2 secant squared beta minus 3 secant beta minus 4 secant beta plus 6 equals 0. Then I factor by grouping, and I will get secant beta times 2 secant beta minus 3. Out of these two, I can factor out a negative 2. And that leaves me with 2 secant beta minus 3 equals 0. I get secant beta minus 2 times 2 secant beta minus 3 equals 0. So then I'm going to solve these just like I've been doing, right? So I get secant beta equals 2, but I don't want secant. I changed secant into what? Cosine. So cosine of beta equals 1/2. Then 2 secant beta equals 3. So secant beta equals 3/2, which means cosine beta equals 2/3. And then I'm going to move over here so I have some more room. So I end up with beta equals the cosine inverse of 1/2, and beta equals the cosine inverse of 2/3. All right. Figure those out. Now, these are both cosine inverse of positive values, so I'm going to use the same 2 quadrants for both of them. But it's possible that one can be positive and one can be negative, so then you just pay attention to your quadrants when you're doing this. All right, so that means that cosine is positive in the first and in the fourth. So I'm going to have alpha and 2 pi minus alpha. Okay. So here, find your alpha and your betas for this first one. What is the cosine inverse of 1/2? Pi-thirds. Remember, you use the decimal unless it's a value you know. You know that one, so that needs to be an exact form. Okay? It's pi-thirds. So that means I need my beta is the first and the fourth quadrant pi-thirds angle. So beta is pi-thirds and what? 5 pi-thirds. Don't make it harder on yourself like, okay, I got to do 2 pi minus 5 pi-thirds, because you know how to do that. We've been doing that. All right, now, is this second one a special angle? No. So this one is going to give you a decimal. So find the alpha for that one. .841 something. Okay, so then I need alpha and 2 pi minus alpha. Find those. And then for this one, you wouldn't need to store it. I mean, you can, but you don't have to. .442. So now we have to put them in order from least to greatest. So I know you have a calculator in front of you, but let's try to use our brains instead. All right? Your built-in calculator, because we don't have to have exact answers here anyway. So my beta, starting from least to greatest. So I have to decide which one is smaller, the .841 or the pi-thirds. Well, pi is a little bit more than 3, so pi divided by 3 is going to be a little bit more than 1. Make sense? So that means that this is the smallest number between these two. So I'm going to start with my .841. Next one will be pi-thirds. Okay? Now let's think about what we know about the unit circle. I've got pi-thirds, which is about right here. Ugh, except I can't write. And then that means that my .841 is, I don't know, somewhere less than that. It doesn't matter if I'm right or not. So when I go around to the fourth quadrant, I'm going to have 2 angles here. Now, knowing about the symmetry and all that kind of stuff, when I'm going around least to greatest, if this is pi-thirds, when I get back around to this angle, is this my exact value or my decimal value? Don't these reflect? Remember how we reflected all those triangles? So if this is pi-thirds, this is the other pi-thirds angle, right? So that means the next one you come to is the 5 pi-thirds, and then this one reflects this one, so it would be that. You could estimate it using the estimations in your head again. You could type it in the calculator if you had to. I just wanted you to kind of also be able to use some reasoning. So then it would be 5 pi-thirds, and then it would be 5.442. What questions do you have? We good? Make sense? All right, so you got lots of time to work today so that you can make good use of that time with those calculators. Don't forget that you have quiz tomorrow on 5.8b, and let me know if you have any questions.